Okay, so you wanted me to do what?
The limit as x approaches 0, e to 2x to 2x minus 1 all over x.
Alright, so we need to make sure we're in LHopital form. So first thing to do is I'm going to plug in the 0, 0, and I'm going to see if I get a 0 over 0 or infinity over infinity. So when I do that, I'm going to get e 2 times 0 minus 1 over 0. Well, 2 times 0 is 0, and that leaves us e to the 0 power minus 1 over 0. Well, anything to the 0 power is 1. So we now have 1 minus 1 over 0, which results as 0 over 0. So since it's in 0, 0 form, we're able to do LHopital. I know, hold on, I gotta mark my edges. Sorry, I gotta mark my edges. Alright, I'm gonna be teaching going that way, there, and very narrow. Alright, so from there, we're nowhere in a 0, 0 form. So we're able to use LHopital by taking the derivative of the top and the derivative of the bottom. So I think yesterday y'all were struggling with the chain rule, doing the chain rule by hand, right? So what we're going to do is we're going to look at the top, and I'm going to take the derivative of the top. So I have e to the 2x minus 1. To take the derivative, I'm going to do U-Substitution. I'm going to show you U-Substitution instead of trying to memorize that chain rule that most people struggle with, right? So I see this as a composite function. I have e to the x, and I have 2x. So there's two functions there. They're composites. So I'm going to do U-Substitution. So I'm going to go ahead and say u equals 2x. Right? And I'm going to take the derivative of this, and I'm going to say, I'm going to take the derivative of u with respect to x, du dx. Derivative of u with respect to x equals 2. And this leaves me eu minus 1. Now I'm going to take the derivative of eu minus 1. And this is really the implicit differentiation where Chandler said, hey, can we go back over that? I'm going to have to go back over that to find some time. I may cut out the shell method and show you implicit, because implicit is more likely on the text than the shell method. But in implicit, you would do like derivative of y with respect to x, derivative of z with respect to x. So you're taking derivatives of other variables with respect to x. So that's what I'm going to do is I'm going to take the derivative of u with respect to x. So derivative of e to the u is going to be e to the u with the derivative of u with respect to x. And the derivative of constant goes away. So now all I'm going to do is just back substitute. Well, I've got e to the u. What I do is 2x. So e to the 2x. And du dx is what? So we have 2e to the power of 2x. So that's that first derivative, the almighty first derivative. So I can rewrite this as the limit as x approaches 0, and now I have 2e to the 2x over, well, what's the derivative of x? 1. Now you got to remember, in AP Calculus, they don't really need to see the derivative at this point of you working it out, because they're really looking for, hey, can you do L'Hopital's rule? Can you take this limit? All right? So remember, you've got to write the limit as e to the 2x minus 1 equals 0, blah, blah, blah. You've got to actually write all that out. But now from here, this simplifies down to the limit as x approaches 0 of just 2e to the 2x. We substitute in, we have 2 times e 2 to the 0 power, or 2 times 0. That becomes 2e to the 0 power, and then once again, anything to the 0 power is 1. Perfect. So that just simply gives me 2 times 1, which is just 2. So that would be the limit of this. Cool beans? Yes? Okay. What's your question?
Why do you, how do you get 1, or why do you put 1 there in x and 2 in a?
Right here? What's the derivative of x? It's just 1. All right, cool beans. So we are still doing L'Hopital. Just I want to show you something that is kind of common. They try to sneak it in on you guys to kind of confuse you. They're going to sneak it in to make sure you're checking. They are going to say something like this. Well, first and foremost, let's do this one. The limit as x approaches 1 from the right of the integral from 1 to x cosine theta d theta over x minus 1. So I want to take the derivative of this. So it's coming from the left, right? Coming from the left. Oh, it's coming from the right, so the numbers are larger. Sorry, coming from the right. So when I plug this in, the question is, what do I get? I plug this in, what do I get? So I'm going to integrate from 1 to 1 cosine theta d theta. What is this? It's 0. Whenever you're integrating from with the same numbers, it's always 0. So that's clearly going to be 0. And then this is going to be 1 minus 1 equals 0. That's clearly 0, right? You got to remember you've got to write the limit as x approaches 1 from the right, the limit as x approaches 1 from the right, and then you can say, therefore, we can use LHopital. LHopital's rule. Alright, so we can use LHopital's rule. So then the question is, I'm going to take the derivative of the top. Let's see if you remember how to take the derivative of the top. I need to do d dx to the integral from 1 to x cosine theta d theta. What is that? What is that? It's just cosine. It's a fundamental theorem of calculus, right? So this just equals cosine theta. And then what's the derivative of the bottom? So for your d dx of x minus 1, it just equals 1. So now I'm really asking you, what is the limit as x approaches cosine theta over 1? Approaches 1 from the right. So, okay. So when we plug this in, what is cosine of 1? An axis.
0, 1.
No, this is a calculator. It's a calculator question. Because it's not like pi over 2 or 0 or pi or 180. What is cosine of 1? Guys, you'll have calculators. You'll have calculators.
0.9998.
0.9998. So it's about 1. Right? It's about 1, but I'm going to put this little decimal right there so you know I rounded. So it's about 1. 0.9998. So it's about 1. Because you got to remember this. Also, do you remember what to do if it wasn't just straight cosine? You have to do the chain rule part, or if it's up here, you have to do the chain rule part. Right? Like if this was 5x, it would change. It would be 5 cosine theta 5x. Or 5 theta or something like that. Okay, cool. This went in terribly bad. Yeah? Yeah? Okay. They may slip something in like that to you. That wasn't that bad. Or they may do something like this. Can I erase? They can do this to you. want you to find the limit as x approaches infinity of e to the negative x square root of x dx. Okay, so you got to be careful with this. Because when you plug in infinity, what do you have? Is it in L'Hopital's form?
No.
It is not in L'Hopital's form. Can we rewrite this? Can we rewrite this part in L'Hopital to get it in a L'Hopital form? How? So take this and just make it a denominator? Get rid of that negative? Absolutely. Sometimes they hide it, and you use L'Hopital, you may have to just rewrite it in the form. So you can have the square root of x over e to the power of x. Now what does this become? If I plug it in, what's the square root of infinity? Infinity. What is e to the power of infinity? Infinity. Is infinity over infinity one of the ways we can use L'Hopital? Yeah, absolutely. So at this point now we can just take the derivatives and see what we get. Yes? What is the derivative of the square root of x?
Yeah, that.
Yeah, right?
Okay.
Y'all should have done that one so much, you should have that memorized. Right? And then what's the derivative of e to the x? E to the x. We have this now. Which turns into 1 over 2 square root x, and we have e to the x.
Yes.
Don't forget we still have the limit as x approaches infinity. So I have 1 over e to the infinity times 2 times the square root of infinity.
Basically 0.
So basically, we got 1 over infinity, which is 0.
Wait, yeah.
Yeah, 1 over infinity is 0. So guys, the worst that they can do to y'all at L'Hopital, you see it's not hard, is they can hide it like this. Where you have to rewrite it. Or they're going to make you do the fundamental theorem of calculus, but that's not difficult. But they could do like, they could have like that integral. Like if I asked you to take b dx of, say, 3 to 4x cosine theta d theta. Gotta remember how to do that one? The chain rule. Yeah. So we take the derivative of here, then we take the derivative of this, and then we just leave this, and then we put that back in there, right? So would this be 4 cosine 4x? Cool. So really with L'Hopital, not hard. What they're going to do is they're going to try to hide it and try to confuse you. But in the core, if they're asking you to do a limit 9 times out of 10, it's not going to be a straightforward limit on the test. It's going to be a L'Hopital limit. Just know that. On all the release tests that I've taken, every time they've asked me to take a limit, it's been a L'Hopital limit. It's not been a straightforward plug-in limit. Cool? All right. Now, let's move on. What we're going to do now is we're going to find the area under the curve. You're like, wait, we've done that. Yes?
Yeah.
But we're going to take the area, instead of under the curve, we're going to take the area between two functions. Where did my other paper go? So we're going to do area between two curves. I'm going to let you see if you can figure out the concept. Nope. So let me draw 2 functions here. Let's say I have one like this, and I have another one that comes in like this, and I want to know how to find this area. Let's call this f of x. Oh, I do that horribly. I want it all to be in quadrant 1. All right. It's okay. I do things the hard way. And I want to find this area. We're going to call the top one f of x. Let's call the bottom one g of x. How do you think I find that area?
Subtract the g of x from that other area. When you find the area under the curve.
So what are you saying to do?
Find the area under the curve of both f of x and g of x, and then subtract the g of x from that.
Y'all hear what he said?
Yeah.
He's saying find the area from A to B of f of x dx and subtract the area from A to B of g of x dx. Sounds reasonable? Because then we're basically going to take this part, the bottom part out. Well, then can't I just rewrite this as the area of AB f of x minus g of x? Yes. Yeah. Because didn't we split these before? Before we have this and we would split it. Here we have this and we just put it back together. And that's it. That's how you would find the area of the curve. But sometimes you have to find A and B. How would you find A and B?
Count.
You have to find where they intersect. How do you find where they intersect? Set them equal to each other. It is on it today. You find A and B. You're going to do f of x equals g of x. If they're not given to you. If they're given to you, that's easy. Right? But if they're not given to you, just set the two functions equal to each other. Do some algebra. Find the two places where they intersect. Then you have your A and B, and then you know, hey, I can just do f minus g, which we can subtract functions, which you learned in Algebra 1, when you're combining functions, subtract functions. So you simplify the integrand down, and then boom, you do the integral. That's it. Area between the two curves. That's the concept. That's the concept. Nothing crazy. Nothing crazy. Now keep in mind your f of x has always got to be greater than g of x. Always. So let's start. Y'all ready? All right. Everybody got this down? I have people writing in the back. I'm going to wait. What time y'all get out of here since there's no bells? 40? 40, ready.
You could have lied it.
You could have said 20.
Yeah.
I would be like, okay. Time to back up. You have to lie to me.
That quick.
Wait, I'm almost done. It's okay. Make sure you get it down correctly. You got to understand it. Like, we're going to take this and we're going to use this on the next thing. Because area is going to lead to what? In geometry, you did area and it led to what? Volume. So we're going to go from this, find the area, we're going to find volume with it.
What's after volume?
Great question. I'm not even sure. I don't even know what's after volume. I'm sure there's something in the fourth dimension. Feel good? All right. You incorporate pretty much anything, I think. Okay, here we go. We will start out nice and easy. I'm going to say y equals x squared plus 2, and y equals negative x, and I want the area between 0 and 1. So I want the area between 0 and 1 between these two functions. So step 1, I'm graphing this. Right? I'm always going to graph. Guys, if you haven't realized, I graph a lot of stuff. I draw it out. I even told my kids in geometry, draw it out, draw it out, draw it out. So I'm going to draw out what's going on. X squared is a parabola. X squared plus 2, how does that actually look? Does that move left, right 2, or up or down 2?
Up, down.
Up 2, right? And then it just looks like a regular parabola. So right here is 2, and we're looking like a regular parabola. Alright? And then y equals negative x. That is right here. Well, they will touch somewhere up here, eventually. But that's why you're told to find the area between 0 and 1, because this time they don't touch. They don't have to touch for us to find the area if I give you the bounds. Right? So I'm going from 0 Let's call that 1. So we're looking for that area right there. That's what we're looking for. Alright, so we're looking for that area right there. So the question is, what's the top function, what's the bottom function? What's the greater than function? Which one's going to be the f of x? And which one's the g of x?
X squared plus 1.
Okay. So all we're going to do is we're going to integrate from 0 to 1, bounds, my f of x, which is x squared plus 2, minus my g of x, a negative x, dx. Right? Now, let's just simplify the integrand. You good? I see you have a little look on your face. Okay. So we're going to integrate from 0 to 1. Well, a negative becomes a positive. I have x squared plus x plus 2 dx. And we integrate that. This should be 1/3 x cubed plus 1/2 x squared plus 2x from 0 to 1. Am I right? And then fundamental theorem of calculus, we haven't done it in a while. What am I going to do with those numbers 0 and 1? So I'm going to plug in 1 first and then the 0? Do I have to plug in the 0 for the AP test?
Yes.
Yes, absolutely. Good. If you don't, you know what's going to happen. You're going to get points, and you'll be like, this is what I'm plugging the zeros in, and I'm going to smack you. Alright. Yeah, you can't tell me that. You're right. So we're doing 1/3 times 1 cubed plus 1/2 times 1 squared plus 2 times 1 minus 1/3 times 0 cubed plus 1/2 times 0 squared plus 2 times 0. Alright, cool. So that's the AP part done. So this comes down to 1/3 plus 1/2 plus 2. So I'm going to have 6 as my common denominator. So this is going to be a 2 plus 3 plus 12. Did I do that right?
Yes.
So 5/17 over 6. And that is what I got on my paper. So is this thing terribly bad?
No.
No.
Unit squared.
Unit squared, correct.
We have to put that on the AP test, they don't use it.
They will always give you units. They will always give you units. I get lazy, but they will always give you units. They'll give you centimeters, they'll give you feet, they'll give you miles, they'll give you kilometers. Kilometers. We're about to do the kilometer for 5 minutes. Wow. They're not giving you kilometers, they're going to give you kilometers. Okay, can I erase? It's your turn to try. I'm erasing. Yeah, basically it's like try today. And guys, once I write the problem up, I'm going to go over and hit mute so y'all can talk louder. Alright?
I got some words for you, Chandler.
Wow. Alright. Y equals x plus 3. Y equals a negative x squared. And I want it between 1 and 3. Okay, I'm going to give you guys time to work on this.